You're welcome to week 8 of the course. For this presentation, it's going to comprise of the information for this week and next week. So feel free to replay the presentation next week, or you can play this through the first half and then play the second half when we get into next week. In the last 6 weeks, we've been talking about epidemiology. We also talked about the two main branches of epidemiology, which is analytic epidemiology and descriptive epidemiology. For the first half, we've spent a lot of time talking about descriptive epidemiology. We talked about different data sources, and that led us into the different study designs that we do have in epidemiology, which serves as a way for us to gather the data that we use in the field of medicine, public health, and science. If you remember clearly, I told you that descriptive epidemiology serves as the foundation for analytical epidemiology. And when we talk about study designs, we have categories under those two main branches. And the two main categories are either observational or experimental. The key difference between both is that the investigator or the researcher has the ability to control what happens in the research environment, meaning he or she can manipulate variables, and this would include the ability to randomize. So one of the key differences between observation and experimental is that the investigator does have the ability to randomize in that setting. You've seen the slide several times, and the reason I'm repeating this is just so that you can get the message. I think this is probably the third or the fourth week that I've put up this slide. It's going to be very similar to what's on the next slide, but that's to kind of help you understand how these study designs are categorized or can be understood. So we started off talking about case reports, case series, ecological studies, and moved on into cross-sectional studies. And I believe the last two we did spend time on in the last week. In the next 3 to 4 weeks, we will be moving to the analytical branch of epidemiology, where we would focus on two main types of observational study designs and the one main type of experimental study design. Remember from that diagram I made available to you in terms of when you're looking at the hierarchy of the different study designs, we move from case report being the lowest on the hierarchy. We go to case series, then we go to ecological studies, which has its own benefits and uses, and then we go to cross-sectional studies, which in some instances I said that there might be cases where you would say considered as analytical because we may be able to estimate odds ratio for like an exposure or for an outcome for that particular setting at that point in time. But it's typically a descriptive study design. And one of the key benefits of having the descriptive study designs is that it helps us generate hypotheses that we can now test in an analytical setting, whether it's observational or experimental. Again, this you've seen before. It's kind of the same thing I just discussed on the previous slide. So now moving to where we should be focusing our time and attention in this week, I will be talking about case control and cohort study designs. Like I stated a few slides earlier, they're considered observational studies, meaning that while there's more rigor associated with these study designs, the investigator or the researcher still does not influence what happens in the natural environment. All he or she does is observe what happens in the natural environment to determine the association of the relationship between an exposure and an outcome. So let's start with case control studies. One of the first questions I'll ask you is, what is the hallmark of case control studies? The simple answer to that is that case control studies are defined by disease status, meaning the outcome would already have existed or happened, and then you go backwards in time or retrospectively to determine what exposure may have accounted for this particular outcome, which could either be a disease, health-related event, or health problem. It doesn't necessarily always have to be a disease, so it could be whatever it is you choose to define it as. So for this slide, here is a presentation of how case control studies are designed or carried out. So as you can see, you usually would start with the general population, identify an outcome of interest. So in my example, I would say a particular disease of interest that you want to study to identify what exposure may have resulted in this particular disease or outcome. So you identify the general population. From that general population at baseline, you identify those cases and get controls, which will serve as the comparison group. Note that the controls do not have the particular disease or outcome of interest. They might have other conditions, that's fine, but you want to make sure that the control group that you're using for this comparison does not have the disease or the outcome of interest. And then you would follow them retrospectively or back in time to identify possible exposures, right? And then link it to the outcome, all right? Sometimes people would wonder, well, what makes case control studies very relevant? Though this design does have its limitations, it's actually proven to be very, very, very beneficial in public health planning. For example, in the United States, where you hear about salmonella outbreaks or hepatitis A outbreaks and things like that, the Centers for Disease Control and Prevention primarily uses case control study design to identify potential causes, right? Potential causes of a particular outbreak or condition. So it's almost like the first, when we're on the analytical arm, it's almost like always the first design that's undertaken to identify an association between a particular exposure and an outcome. Right, so that's why it's very important. But in the subsequent slides, I will explain in more detail why a case control study is relevant. So here we have it that it's used in understanding the cause of a specific disease or outcome of interest. So again, for example, risk factors for death from a violent injury. It helps in measuring effective procedures or interventions. Example, screening programs. I just stated this earlier about the investigation of disease outbreaks, which is used by the CDC very often. It's also very useful for studying diseases with long latency period, meaning a disease that takes a while before it eventually manifests. So in as much as we may think in theory that these research studies are very easy to implement, in reality, they're not. They're influenced by a lot of factors, which would include resources, that would be money for staff, ability to follow these individuals over time, which would also include when they travel from one place to the other, you need to be able to track them. So if a particular disease is known to have a long latency period where, it might take 10, 15 years before the disease actually manifests after exposure, it makes sense to use a case control study where you would study those individuals who already have the condition and then try to go back in their history to see what may have contributed to this particular disease or outcome. Um, Case control studies are also very useful for studying rare diseases where a large number of cases would be difficult to recruit. Okay, so please pay attention to this because sometimes you might be given a scenario and approached as an epidemiologist or someone who's trained in epidemiology to suggest or identify a feasible study design to actually study a particular association between an exposure and an outcome. You want to make sure you take a lot of factors into consideration. You want to understand a little bit about the disease. Is it a short latency period? Is it a long latency period? Then, of course, you go into your resources and a whole bunch of other factors, the ability to find this patients and things like that. So if a particular disease is rare, it means that it would take a while for you to identify enough people to make your sample relatively large. So in that instance, it would make sense for you to use a case control study. I already briefly talked about some of the strengths and weaknesses of a case control study, but this slide kind of summarizes it again. So I don't mean to sound redundant, but the more you hear about this, I think the more it would help you identify which study design will be more or most suitable for your circumstances. So let's talk about the strengths first before we go to the weaknesses. Like I stated on the previous slide, it allows for the study of rare diseases. It can be conducted over a short period of time when you compare it to other advanced analytical study designs such as cohort studies and experimental study designs. But of course, this requires more resources and more time um, compared to the other descriptive study designs that we previously talked about in the past weeks. It also is used to determine etiology of disease. So again, that's why it falls under the analytical arm, where we may be able to establish causation. Establishing causation is very uh, challenging, but it's actually possible to do that using the study designs under the analytical branch of epidemiology because there are a lot of more advanced um, concepts you'll be able to employ to help determine that. It's relatively inexpensive compared to cohort studies, but nothing in research is 100% free. You also saw that from your cross-sectional study design exercise. It was a good way for you to think about it because you might say, well, I'll hand out incentives, but you need money to hand out the incentives. If you were disseminating a questionnaire and you needed to do it via a server, you might need to pay for the subscription for that server. You know, you need to hire people to actually disseminate the survey, and you just have to remember that time is money. So going back to case control studies, compared to cohort and experimental study designs, it's relatively less expensive, but could still be expensive. You're also able to calculate prevalence of exposure in the sample population. So be careful here. In the event you get a question asking, what measure of frequency can you compute or calculate or estimate from a case control study? You have to remember that the case control study is just a subset of the general population, so you don't have the total population information at hand. And you have to also remember that you established a study based on disease outcome. So it would not make sense for you to estimate the prevalence of the disease you know, in the study. However, because you're not sure of what the exposure status is at the time you initiate the study, you may be able to calculate the prevalence of exposure in the sample population. I hope this makes sense to you. Let me know if you need more clarification on this. Send me an email, post this on the discussion board. Just think about it first, okay, before you accept it for face value. The other strength is that you can study multiple exposures for one particular outcome. So again, because you're trying to identify or find what the potential cause of a particular disease is, and since you're going back in time, when you're interviewing or talking to these cases and controls who are free of the disease, you may be able to establish more than one exposure that may explain this particular outcome that you're observing. Okay, I hope that makes sense. In terms of weaknesses, one of the biggest weaknesses of case control studies is recall bias. Again, why this is big, if there's anything you don't remember about the downsides or the weaknesses of the limitations of a case control study, it's the fact that recall bias plays a key role. Because sometimes these people, depending on the nature of the disease, they've probably forgotten about what they may have been exposed to years and years back. There's also the tendency for people to, miscommunicate or misrepresent something, based on how they feel at the moment, which some of you picked up on when you were conducting your cross-sectional study exercise from last week. Correspondents or participants may respond in a way that they think the interviewer or the researcher or the investigator wants them to communicate. So this is a major problem here. However, it doesn't totally underestimate the power of case control study designs. So when you conduct a study like this, depending on the nature of the condition, what the sentimental values associated with the questions that are being asked, you want to make sure that you take this into consideration when you're interpreting the results of your findings from case control studies. The other issue is that they can be incomplete. Again, this is somewhat linked to the recall bias because you're going retrospectively, which could be over a long period of time. It may be very difficult for you to identify the key information that you need to make your conclusions. Because it's retrospective in nature, remember we said incidence is the number of new cases that you have in a particular population, usually a population at risk or a particular outcome. Because this is retrospective in nature, you're unable to directly compute the incidence or the incidence rate. Please make note of this. You cannot compute incidence with case control studies. Similar to all of the points made earlier, you also stand the risk of confounding. Again, because there might be multiple factors that are associated with a particular outcome and the exposure, it's sometimes very difficult for you to be able to eliminate these confounding factors. We will address confounding in more detail when we get into the statistical methods used in epidemiology and when we also start talking about bias and confounding. So all of these points that I'm making here are not irrelevant. We will approach them in more detail as we make progress in the course. Another weakness with case control studies is that you're limited to a single outcome analysis, meaning while you're able to study multiple exposures, right, you can only study one outcome at that particular point in time. Why is this? Remember, you're starting with the outcome already. Your outcome is the baseline, and you're going back in time, right? When we get cohort studies, this would be flipped. All right, so you can only study one outcome in a particular analysis, but you can study multiple exposures. And number two, and the last point I want to make as well is that you're unable to estimate absolute measures. So remember I said for measures of association in epidemiology, we have relative and absolute measures. Relative measures include odds ratio and relative risk, and absolute measures would include like attributable risk and things like that. And if you remember, the formula for attributable risk involves you computing incidence. As such, because you're unable to compute incidence in case control studies, you will be unable to measure an absolute risk. All right. However, you will be able to measure a relative measure, which would be the odds ratio, because that does not include incidence. I hope this makes sense. Again, from the discussion exercise, we would explore this in more detail. Please let me know if you need further clarification in these concepts as we make progress. Okay. So we've talked about, we've given you an overview of what case control studies are, why case control studies are useful, what the strengths and weaknesses are. So now I'm going to now start, tearing or dissecting the study design into different forms. So remember we said that the hallmark of case control studies is that you begin with the disease or the outcome, and you go back in time to identify the exposure. In order for you to conduct a case control study, you need to identify your cases and your controls at baseline, right? How are these people selected, right? So you would have to ask this question when you know what your actual outcome of interest is. So let's say it's a particular disease, right? Maybe in a particular geographic area, or you've observed this in several geographic areas. The best places sometimes for particular diseases would be identifying the cases from maybe like a hospital, a clinic. You get them from there. Once your cases have been identified, you have clearly defined what a case is, and all of your cases meet that criteria or definition, then you need to make sure that you select controls, which serve as the comparison group, that are similar to your case group, but different in terms of the outcome of interest. So let's say you want to study breast cancer in a particular group of women, right? Your outcome or your disease is breast cancer. You want to make sure that your definition of breast cancer, is clearly stated, and every case or every woman that you include in that breast cancer category meets that definition, which would most likely be a clinical definition. And for the controls, you want to select them in a way that they're similar to the women in the other group. And remember in epidemiology, when we talked about descriptive epidemiology, we talked about, this distribution in terms of person, place, and time. So again, if you're looking at the person, you want to make sure that they have similar characteristics with the exception of the outcome of interest. You could do it based on place, meaning, they all live within the same geographical area, or they might be identified from the same geographical area, or time, meaning you can, pick the controls based on the same period of time you believe, matches what the case group will be. What are possible problems with control selection? We run into control selection when, we haven't properly, identified or defined different variables in the study. As you would notice from the assigned readings, there are different kinds of controls that we would have. They could be selected from the person's family, so we might be able to identify controls um, from like the immediate family, from the same neighborhood, maybe from the same work setting, from the same, you know, let me think, from the same um, uh, employer, from the same income bracket, from the same, what's the word? I'm trying to think about it. Profession. These are ways you can identify them. Again, sometimes you can identify controls from, the hospital or clinic setting. So this would be what we call hospital or clinic-based controls. We also have those that are considered nested case control groups, which I'll talk a little more about when we get into cohort studies or the subtypes of case control studies that we have. But the take-home message really here is that controls can be identified in several ways. It could be geographically based, it could be employment based, it could be professionally based, it could be familial based. Just make sure that you're identifying the right control group for your analysis. Same as with some of the limitations or weaknesses that I mentioned in the previous slide. Other problems that are associated with control selection is there might be biases in terms of age, socioeconomic status, race, and some of these other factors that are innate to the individual or environmentally influenced, but there are ways that we can actually adjust for these to minimize this bias that we might run into. And this is through a process known as matching, where you match the controls to the cases based on those particular factors. So this way, you remember when we talked about standardization for rates when making comparisons, this is kind of something similar, right? Where you're trying to eliminate the effect of, age as a factor, or socioeconomic status as a factor, or gender as a factor. This is what we'll be doing here to minimize any bias associated with our study. And then another key question that you should always ask, or people tend to ask, is it possible to have more than one control group in a case control study? The answer to that is yes. However, most of the studies that you probably run into always shows one control group, but there are instances, if you do have the resources and you do have access to the patient population, you could actually have 2 or 3 control groups, comparing them to the case group. This is, usually great if the study is well done, because now you can, really study multiple exposures related to one particular outcome. But what you would tend to run into will be mostly a single control group. Okay. So let me talk about matching in further detail here. What is matching? Matching is the process of selecting controls so that they're similar to cases in certain characteristics. Again, this is just what I stated on the previous slide. How do we do this? It can be done at 2 levels. One is either at the group level, meaning that you take, let's say in the case group, we have in the case group of 100 participants, right? We have 50% distribution, maybe based on gender, so 50% males, 50% females. In your control group, you want to make sure you have the same distribution, 50% males, 50% females. So this is done at the group level. It could also be done in maybe using age groups. So let's say in your case group, you have 3 age categories. So maybe you have 25% are aged 18 to 40, another 50% are aged 41 through 60, and then another 25% are aged 61 and above. You want to make sure that in your control group you get the same distribution where there'll be 25% age 18 to 40, 50% aged 41 to 60, and then the remaining 25% are 65 years and above. So that's one way to do it if that's easier for you. The other way to do it also would be at the individual level where each case is matched to another case in the control group. Looking at both, I bet you can tell which is a lot easier to do. It's actually a lot easier to do it at the group level where you're not looking for one exact match per individual. You're just looking at them in categories. But again, this is me. You really always have to pay attention to the context to know what will be most suitable and most appropriate for your purposes. Okay, so whatever seems a lot easier, as long as it will yield reliable results, then go with that. But just know that there are two ways that we can address this issue of confounding. Are there problems, with matching? Absolutely. Matching can be very cumbersome, which is why when you're designing your study, you want to make sure that you include or involve a biostatistician at the onset so that they can help you sort all of this out and figure this out before you embark on the study. Because when you start the study, you get halfway and find out that what you did was incorrect, or this is going to cause you more problems than you anticipated, then it's almost kind of like a waste of time, which is something you would not want to run into when you have limited resources. So just note that while matching is a good way to address potential confounding or differences in case control studies, it has its limitations and problems as well. It has to be done well for it to have any impact. If it's not done well or properly, then it's almost as if you did not employ this skill or this concept to your study. So you will still stand the same risk of those factors being a confounder. Okay? Okay, so I've talked about the overview of case control studies, the strengths and limitations, how controls are identified, potential shortcomings of case control study designs, the concept of matching to address some of the potential shortcomings. Now I'm going to move on to two last sections, which would be the subtypes of case control study designs and the measures of frequency and association that are possible in case control studies. Again, a lot of this I already addressed previously on the previous slides, but I'm just reinforcing it or restating it so that you understand that this is a very important concept that you must take away from this course. For case control studies, we have several subtypes. So we have the standard case control study where, like I said, you have the cases, you have the controls, which could be one or more groups. We also have instances, and in that standard case control study design, the controls are independent of the cases, meaning the controls are completely different individuals and the cases are completely different individuals. However, there are certain scenarios where the case could serve as the control group. And this is where we talk about case crossover study designs. The textbook actually explains this to you in detail, even though we would really not be employing that in this course. But I just want you to know that this is possible, where while they're looking back in time, there might be something that's observed or triggered where we can actually use a particular case as its own control group. Maybe at a point where its status changed, right? And then we can compare that case to itself. So that's where we'll call it a case crossover study design. But it's a subtype of case control study. So if you were to run into this, while you would say it's a case crossover study, which you would also have to say which is the form of a case control study. We also have what we call the nested case control study. And the nested case control study is usually formed within an existing cohort study. So again, when I get into cohort studies, which I will talk about, it's usually prospective, but sometimes while you're conducting a prospective study over time, things may happen over time where you would actually now go within that cohort study and say, you know what, we identified this at this particular point in time, even though that was not the primary outcome that we were looking at then. But because we've seen a lot of these outcomes happen within this cohort, we need to go back in time within that prospective cohort study to identify when the exposure occurred. So this is where we now have the nested case control study within a cohort study. And the bottom line here is that the same principles associated with a case control study design would apply in both scenarios. Okay, I'm highlighting this so that if you run into this, in your careers after this course is long over, you would know that those study designs do exist. Okay. So in the last 2 to 3 weeks, you've run into 2x2 contingency tables. Even though I never highlighted it in any of my presentations to you, the PowerPoint slides from the course textbook does have them. So 2x2 contingency tables are very, very useful in epidemiology. And for people who are more visual learners, it's actually very helpful. So at times when I give you scenarios to address, sometimes it usually helps for you to just develop a 2x2 table and try to plug in those numbers into the 2x2 tables to help you understand what it is that you're doing rather than trying to read the text. So in epidemiology, you would notice and see that we tend to use the 2x2 or contingency tables very frequently. And while there's really no general convention and how to set it up where maybe the cases and the non-cases are in the vertical columns, while the exposure status are in the horizontal columns. This is pretty much, I think, easier for a lot of people to use. Just make sure that however you set them up, right, you are actually able to do your calculations correctly. So for me, and which you would see for a lot of other textbooks that you would run into, this is pretty much how we set it up, where I make the cases or the outcome status in the vertical columns and the exposure status in the horizontal columns. And for those of you that memorize your formulas based on A, B, C, D on there, you want to make sure that the way you set this up, the way you've put in your A, B, C, D does apply correctly. Like I stated a few slides ago, the only measure of frequency that you may be able to estimate from a case control study would really be the prevalence of exposure specific to the sample. Again, because you don't have the information of the total population, you cannot estimate the prevalence of the total population. And again, because you're starting with disease status or outcome status in a case control study, it would not make sense for you to estimate the prevalence of the disease because you selected your the number of cases that you have, and also determine the number of controls you would have. So it would not make sense for you to estimate that. However, because you're trying to study exposure and at baseline, you don't know what the exposure status is of your sample population, you may be able to estimate the prevalence of exposure specific to the sample, which you use the same formula as number of existing cases, right? With a particular exposure, right? Divided by the total sample population, okay? So again, the numerator is number of exposed. This would include both cases and include disease and non-disease, all right, divided by the total sample population. I hope that makes sense. With regards to measure of association, like I stated earlier as well, you can only measure a relative measure in case control studies. And this relative measure will be the odds ratio. Why? Because you're unable to estimate incidence in a case control study. And I already taught you how to estimate, how to calculate or compute odds ratio. So for this week and next week, we will be doing a lot of mathematical calculations for odds ratios and case control studies. For case control and cohort studies. So this would be a good time to practice using the contingency table and also being able to interpret the odds ratio. I already went over this with you before, so hopefully through more practice and exercise, you will be able to get this right. So on the following slides, I have a few examples for you, and we will walk through that example to see if you're able to estimate or compute the odds ratio in this particular scenario. Okay, so here we have MSD. In this case stands for musculoskeletal disease. So that's the outcome of interest in this particular scenario. And the controls obviously do not have musculoskeletal disease. So they might have other conditions or other diseases, but they don't have my disease of interest. The exposure in this particular case is work history of lifting. So it's either you are, and of course, even though the information is not here, we have a clear definition of what heavy lifting is, and we have a definition of what non-heavy lifting is. So you're either in the category of being a heavy lifter or you're a non-heavy lifter as it relates to the kind of work that you did. Again, it's a history because this is retrospective in nature. So in this particular scenario, we have it that there were a total of 200 people who were identified to have musculoskeletal disease, and we matched them to a control of 400 people. So again, when you're working with your controls, they don't necessarily have to be equal numbers. You can actually have more controls than you have cases. It would actually make your sample size a lot stronger. Among the heavy lifters, 112 of them had MSD, and for the controls, 176 of them had MSD. All right. For the non-heavy lifters, 88 of them had MSD, and among the controls, 224 did not have the outcome of interest. For us to compute the odds ratio here, remember the formula for the odds ratio is the odds of exposure, right? And the disease or cases divided by the odds of exposure in the non-disease or the controls, right? So once you compute that, um, that should be able to help you get what your odds ratio is, and you should be able to interpret that. I didn't complete it here for you in this presentation because I want you to actually do it as an exercise on your own. See if you can actually compute it and interpret what that result is, and then let me know if you encountered any issues while you were computing it. Having said that, I'm going to end case control study designs here. Again, I don't want to be too redundant with what your textbook and the PowerPoint slides that accompany your textbook already has, but I use these presentations to help highlight the key things you need to know about these various topics. There's some fundamentals you need to know, and as time goes on and as you become more conversant and more experienced with epidemiology, you will be able to apply the other concept. But the basics you must know and be able to graduate from this course with. Okay, so that's the purpose of me creating this PowerPoint slides for you. All right, I will end on case control study designs here. And the next half of this recording will be for cohort study designs, which should be applicable to next week. But you could feel free to listen to it now, and makes your reading a lot easier and smoother in the coming week. Or you can pause here and then replay it when you get to the following week, where we will now focus our time and attention on cohort studies, as that will be the focus of the discussion question as well. Okay, so now we will go into the next stage or step in the hierarchy of epidemiologic study designs, which will be the cohort studies. This will be the step right under the experimental study design, which is considered the gold standard of all epidemiologic study designs. So based on this, you can already guess that it has a lot of strengths, and is usually preferred to the experimental study design in instances where there are ethical concerns or issues that may come into play if we decide to use the experimental study design. You would see this from some of the examples in your textbook, some of the examples you read about online, and of course in the group exercise that we will be conducting on the discussion board. So I'll ask you this question as well, which I did when I talked about case control studies. And the question is, what is the hallmark of cohort studies? The hallmark of cohort studies, is that groups are defined by exposure status. If you remember clearly, for case control studies, the hallmark is that groups are defined by outcome or disease status. For cohort studies, the groups are defined by exposure status, which is why cohort studies are longitudinal in nature, meaning you're going to follow those individuals over a period of time. So when you hear the term longitudinal study, it's either going to be a cohort or an experimental study design. Where the difference would lie for those two study designs would be whether the investigator had any control of the parameters um, that took place within the study. Again, remember, cohort study design falls under the observational arm or category of the analytical branch of epidemiology. All right? You, the investigator or the researcher, has no control of the factors. He or she simply observes what happens in the natural environment to determine the relationship of the association between exposure and outcome. I've said this so many times, and I hope people do get the message. So, of course, we want to know what steps we'll need to take when designing a cohort study. Similar to what we've done with the previous study designs we talked about in the last few weeks, you want to have a clear study question, a purpose, an aim. You want to identify the right population. You want to make sure that you're using the right instruments and things like that, which we will talk about in more detail. But now honing it back to cohort studies. This is a slide that's very similar to what I showed you when I talked about case control studies. You would typically start with the general population, and from that population, you identify your participants or your subjects based on the exposure status, right? And you would determine this at baseline, right? So it's either they're exposed to a particular um, uh, factor of interest. So you would have actually had to identify what your exposure of interest is. And then you would also have those who are not exposed to the particular factor, and you would follow them over time to see if they um, develop the disease of interest or not. Okay? So again, for cohort studies, you would start with exposure status at baseline and follow them, right, to see if they develop the disease or not. Under cohort studies, we have several subtypes similar to what we talked about for case control studies. So let me explain this. The one that you would generally run into would be the prospective cohort study, where the exposure has been established. The researcher comes in and starts the study when the exposure is already in place, and then identifies a comparison group and follows them over time to determine whether there's a disease happens. Another way you could also see a prospective cohort study design is that the investigator starts the study, right? The exposure status, you know what exposure status you're interested in, but the exposure actually hasn't taken place. So they design the study and say, okay, we're going to start today, and then knowing that the exposure will be there, right? They start the study and then they start to observe them, over time, and measure, the time the exposure comes into play and see if the disease or the outcome of interest does take place. So this is the one you will primarily run into or see when you hear about cohort studies. It's mostly prospective in nature. Having said that, I know this is going to sound a little off, because we're saying, there's something called a retrospective cohort study, and people would ask, well, how does this differ from a case control study? The difference still remains the same. The baseline is always the exposure of interest, right? And the outcome would always, be the end factor. The way a retrospective or historical cohort study would work will be that all of the information the investigator or the researcher needs is relatively available and reliable, to some extent, almost similar to how it will be if you were doing this prospectively. So meaning, the let's say you have a prospectively um, managed database. So let me use a database as an example. So let's say, being that I work in the field of surgery, so let's say we establish a database where we collect information on every patient who comes in for surgery, right? Over time. Again, at that time, we really haven't established what our exposure is or what outcome we're looking at. We're just collecting this information. So as they come in, we will get as much info on them. So this is a prospectively managed database. But then, maybe over time we kind of say, you know what, we're observing this trend, blah, blah, blah. The researcher could actually now go in there and say, you know what, this is a prospectively collected database. So maybe we can, rather than wait for us to enroll new patients from today, since this is already managed and we've kind of controlled for a lot of the potential factors we may run into, we can, say, okay, we'll start the study today and then set an exposure date. And from that date, start monitoring um, those particular participants who were exposed to the particular factor and comparing them to those who were not exposed to it, and see when the disease or how the disease occurred. Does this make sense? I hope this analogy kind of helps. Otherwise, I can come up with another one on the discussion board. But again, this is typically how it works. And we call it retrospective, but it's still not a case controlled study. It's still a cohort study because our baseline is defined by exposure status and not disease status. Then another kind that we would run into would be what we would call the ambidirectional cohort studies. They're not very common, but that doesn't mean that they don't exist. And this is usually a merge of retrospective and a prospective cohort design, where some of the information has already been collected, or we already have some information from back then, and then we decide to expand our monitoring period to start from a later, an earlier date, and then continue to follow these individuals over time. So I can still build upon the example I gave you of our prospectively collected, prospectively managed database, where, okay, we'll say, well, you know what, we establish an exposure date. Maybe there was a particular implant that was being used or was introduced to the hospital at a particular point in time, and we noticed that our rates of certain complications increased, and we still want to kind of follow these people over time to see if that exposure also contributes to additional outcomes over time. Then this would be a good example where we will use the ambidirectional, where the study would start somewhere in the middle, combining the retrospective and the prospective arms of the study into one. Again, it still doesn't change the hallmark of the study design, because the hallmark of the cohort study design is exposure status. I can't say this enough. I just want to make sure that you understand this principle. Okay, so having talked about the various forms that we do have, with the prospective being the most frequently used, I'm going to also now focus on addressing some key factors that you would run into when we're talking about cohort study design. One of the major factors to take into consideration with cohort study design is the issue of follow-up. You all have highlighted this in your responses to some of the discussion questions that I have posed, where we would say, well, sometimes following people over time, especially if the population is either fixed or dynamic. Sometimes people move from place to place, sometimes people die, sometimes people develop memory issues, and if the study is a relatively long study that takes place over a number of years, after a while people may choose to not be part of the study anymore. So there are a lot of, while cohort studies are very helpful and advanced and have a lot of strengths, follow-up is one of the biggest limitations. And like I've stated in, some of my comments to you on the discussion board, we have to remember that we're dealing with human beings, and sometimes human beings can be very unpredictable. So those of you that may have some history, or experience or interest in behavioral health, you would understand what I'm talking about. So, and again, for research studies, you cannot force somebody to be in a study. When you sign them up, you have to always remember that this is voluntary, and and they would always have a right to decide to withdraw from a study, which would also impact um, your results and the way you interpret the results. I would talk a little bit more about factors to consider when you're designing a study. Once we're done with these basic study designs, because I want you to kind of look at the big picture once you already understand the various designs that we have. Um, for cohort studies, it's also been reported that follow-up for mortality is usually easier than morbidity. And you'll probably ask why. I mean, this is pretty much common sense. Assuming the study is being done, maybe like in a developed country setting where vital statistics are collected, if somebody were to be part of, there have been some studies where people, it's been going on for 15, 20, 30 years, and you're unable to reach them. You could actually log into, like, I think there's a death index or something, or a social security index, where you can enter the person's information and you will be able to pull up the person's death certificate. So this is usually easier for you to know, well, this person died, and it would report the time, the date of death, so that you can, measure your person time when you're computing incidents. Morbidity, on the other hand, is kind of difficult, because if you're not actively following the subjects over time, meaning if you don't have the staff and the resources where they actually follow very, very closely, it may be very difficult to ascertain when a person actually develops a disease. And if you remember, morbidity is the same thing as disease, meaning you having a condition, while mortality is being diseased, where the person is dead. So that's why we say follow-up for mortality is usually easier to retrieve than morbidity. And then other points or factors to take into consideration when talking about cohort studies is changes in level of exposure must be noted and recorded. Um, so let's assume you were conducting a study where you're interested in a particular exposure and a particular outcome, and over time, right, you're doing this prospectively, it's longitudinal, and over time, um, the the individual in the study changes their exposure level. So let me use the example of alcohol consumption, for example. So let's say at the beginning of the study, when you started with the exposure status and you had somebody who was a drinker, right? Whether mild, heavy, depending on how you choose to define it. And let's say as time went on, this person changed their exposure status, meaning maybe they stopped drinking, or maybe they moved from being a regular drinker to a heavy drinker, or maybe they moved from an occasional drinker, or and then now have become heavy. You need to be able to follow that, in order for you to truly measure the association between the exposure and the outcome. And this is sometimes usually very, very cumbersome in cohort studies that require a long follow-up period. So you always, again, like I stated previously, you should always look at the context of your study, and the context would also include geographical area, ethnic differences, cultural differences, when you're designing your studies, because you don't always want to use the one size fit all um, blanket when you're designing the studies, because the way a study is designed here in the United States, even in the Northeast, maybe different from the way it's designed in the South or in the Midwest. Again, because there are differences in the maybe the way people relate with others, or some things are considered taboo, some things that people don't want to talk about. So, these are some of the factors you should always take into consideration when you're, conducting the study. So while a study design might seem, perfect, you also have to make sure that you take your scenario into consideration, your population, and see if this is actually feasible for you to do. So when I'm asking you a question, or when you're doing your final project and I ask you to pick a study design, these are the points I want you to take into consideration. I don't just want you to design a study based on theory without really thinking about what problems you might encounter. So please always take your geographical area into consideration, which is why we always talk about the person, place, and time. Look at the resources you have available. Are they realistic to carry out the study using the design you have chosen? And then, of course, we'll talk about sample size, which I will address in detail again after we're done talking about the various study designs, because I didn't mention it when we were discussing cross-sectional surveys, because it involves a little bit of mathematical calculations, which um, in my opinion would be too early to do now, because you're still learning about the other calculations that I want you guys to master first, which would be the measures of disease frequency and measures of association. Okay, so having talked about the various cohort study design types that we have, and some critical factors to take into consideration, I want to now talk about the strengths and weaknesses. And, you know, this list is not exhaustive, because you might find, a few others from your textbook readings and the presentations that complete the slide, and also from additional things that you find, from peer-reviewed manuscripts and things like that, to add to this. But these are the ones that are very critical that I believe we must address in this course, so that at least you understand the basic principles. So let me start off with the strengths. One of the key strengths of cohort study is the ability to study multiple outcomes for specific exposure. If you remember when I talked about case control studies, because you were starting with the outcome, it was possible for you to study multiple exposures. For cohort studies, because you're starting with um, a particular um, exposure, you can actually study multiple outcomes as time goes on. It also enables you to study relatively rare exposures. If you remember, for case control studies, you can study rare diseases, but for cohort studies, you can actually study rare exposures. So pay attention to that, because the baseline, seems to serve as the factor that would help you determine what the strength or weakness is. For cohort studies, because of your ability to determine or measure new cases, you can actually estimate the incidence, either rate or the cumulative incidence. With cohort studies, you're actually able to provide a clear temporal sequence of exposure and disease, which is what makes it more likely for you to establish a causal relationship with a longitudinal study design, which is like the cohort and the experimental study design, um, as opposed to the descriptive ones, where you are not able to do that. So you can establish a temporal sequence. So if you're actually following these people over time, you may be able to determine, how long um, an individual or subject to be exposed to a particular exposure, in order for them to develop the disease. So this is how we're able to um, learn or know all that we know about, exposure and disease outcomes today. And also because it's prospectively done and assuming that the investigator, takes up or applies all measures to ensure that the subjects are not lost to follow up and that you're actively involved with them, you may be able to reduce recall bias. Remember, we said that one of the biggest weaknesses of case control study design is recall bias. This may be significantly decreased in cohort studies if the study is done or set up properly. So again, notice I did not say it eliminates the chance of recall bias. No, because it depends on the outcome that you're looking at. So if it's a study that's looking at, amnesia or Alzheimer's, where, memory loss is associated with that, it will be very difficult for you to actually eliminate recall bias, unless you're talking to other people who live with the individual and things like that. So note that I said it reduces the chance of recall bias or minimizes the chance of recall bias, but it does not 100% eliminate it. With regards to weaknesses, one of the big weaknesses is that it's relatively expensive compared to the other study designs that we have talked about in previous weeks. It takes a longer period of time to actually execute this study and like if you look through the literature, there have been some studies that have been running for 15, 20, 30 years, if for a study to run that long, definitely it requires a lot of resources. This means that, a lot of investment needs to be put into the study, not only with the recruiters or the people who actually actively stay involved with these individuals. There's some studies where you actually have to offer incentives to your study subjects. And again, if it's a study that is being run across a wide geographical regions, then you kind of have to take all those into consideration, weather, access, a whole bunch of things. So think about all of this when you're designing your study to know which of the study designs would be feasible. And then of course, like I stated earlier, the cohort studies are not suitable for rare diseases because you need a large number of subjects to actually study. So that's why a case control will be most appropriate for that specific scenario. In the following slides after this, I will be talking about the measures of frequency and the measures of association that are possible in cohort study designs. A lot of this we already addressed previously, which is why you needed to know how to compute and interpret those measures of frequency and measures of association, because they're now applicable to these specific study designs. So please, if you still don't know how to compute your measures of disease frequency and your measures of association, please make the time to study this and understand this, because you will need them going forward. Okay, I already talked about the 2x2 contingency table when I talked about case control studies. The same thing would apply here. Again, note that the difference between case control and cohort studies is usually the disease or exposure status. In as much as for the cohort studies, in my scenario, I still have it set up as, the disease and the non-disease being in the vertical columns and the exposure status are in the horizontal columns. As you can see, in this case, I have it that for exposed, it's either the cases, and the non-exposed is usually the comparison group. Again, remember, because our baseline is exposure status. Although I still set it up the same, like I stated, the way you put your A, B, C, D is dependent on how you actually label this this table. If you were to do, if you were to choose to put your disease and non-disease on the as the rows, and the exposure status and comparison group as the columns, just make sure you flip the A, B, C, D that way so that you're sure that it corresponds. Otherwise, when you do your calculations, it will be incorrect. With regards to the measures of frequency that we can measure in cohort studies, we can do incidence would be the primary, right? And of course we can, estimate other measures of disease frequency, which could be like, death rate, and a few other things that I mentioned a few weeks back in the course. But because prevalence and incidence are the two main measures that we use in epidemiology, I will highlight those two. So you can do incidence. It's also possible for us to measure prevalence in cohort studies again, because remember I said that you can actually get a nested case control study from a cohort study, and for cohort studies you can actually estimate prevalence. That is possible in a cohort study, but the main measure of frequency that we will be able to measure in cohort studies would be incidence, and you already know that formula, which would be the number of new cases divided by the total population at risk. Okay. In terms of the measure of association, we can measure a relative measure and an absolute measure. Remember the relative measures, we have odds ratio and relative risk, but specific to cohort studies we tend to use relative risk. That's not to say that the odds ratio cannot be estimated in a cohort study. It can be estimated, and that I will cover in more detail as we move along in the course. But in terms of absolute risk, an absolute measure, we can actually measure the attributable risk, because again that's a measure of incidence, so that's possible for us to do that. Okay, so we can measure a relative measure and an absolute measure in cohort studies. This is the formula, which you should already know from all of the exercises you've been doing in the last few weeks. I really hope you all grasp this. And when given a scenario, you can also, put all of this in a 2x2 table to be able to help you do your calculations a lot quicker. You already know how to interpret your odds ratio and relative risk. This is why you had to learn how to do that before you got here to this point. This is another example here. Again, I did not, it's similar to what I did for the case control studies, only that in this case I'm saying it's a cohort study of 3,000 heavy lifters and 5,000 non-heavy lifters. So as you can see, the sample size in this scenario is a lot bigger, and I already set this up for you. So now take your time and compute the relative risk, and you can also go the extra step to estimate the attributable risk if you believe there's enough information in the scenario you've been given. This is going to also be a clue into any exams that you run into. You may be given a scenario and told to or asked to determine which measures of association you can compute from this. Please always focus on the amount of information you have available. If after thinking through and you look and say, well, the information I have is not sufficient for me to estimate X, Y, and Z, that in itself is a response. Okay, and you will be graded based on whether that information is there or not. So it's all about you being able to think critically. There are times that the information may not be glaring at you, but you need to be able to analyze and assimilate a situation, a scenario, and be able to interpret it in your head and communicate to your audience. Okay, so see if it's possible for you to estimate the attributable risk here. You already know how to interpret the odds ratio and relative risk. I'm just putting this out here because I've already used the slide previously, but this is just here to also help guide you in terms of interpreting the odds ratio and relative risk. It's kind of also similar to how you would interpret the SMR, which is a standardized mortality ratio, which you already did before. And I will end the presentation here because I kind of made a point about this earlier, where I asked, whether the relative risk can be estimated from the odds ratio. Yes, there are instances where this can happen, and this would be when the case studies are representative, when controls are representative, and when the disease is rare. Okay? This would be another lecture in itself where we will break this down because there's some mathematical formulas that are associated with this. I would explain this to you when we get to that point. But for now, I will end the presentation here for cohort study designs, and I will see you on the discussion board.